stuff out. Open up 3-7, right? We finished off 3-7 absolute value. So first things first, we have to check yourself before you proverbially wreck yourself. Everyone there? Okay, if I remember right, we were kind of crushing it on this. And we set you loose right around here. I know I did the word problem, but these are going to have, these two have the parent graph on there. You don't have to do that. I don't care. Remember, it is not enough to just have answers. Answers don't do you any good if you don't know how to do it. It's the test that matters. So I know they have two graphs up there. The one in the middle at 0, 0 is your parent graph. Don't worry about it. You should have the other one. Okay, 7. Just took that parent graph and shuffled it over 1. Oh, I'll be that way. Okay, 8 and 9. 8 moved kind of up into that corner. 9 just down 2. These all turn out okay? I hope. Okay, we flipped it over. I think, yeah, you were responsible for these ones, and I did the word problem. The toughest part about these was probably the scale. Not so much do I go up, down, right, or left, it's the scale. Y'all, we need to get real into this. You should have you better have this written down somewhere. Okay. You got to have that written down. Okay, that is our cheater for not just these absolute value graphs, but remember that's also how we dealt with moving lines up and down. That's also how we dealt with our parabolas, the U's, not V's, moving up, down, right, and left. Okay, you have to have that cheater. And it's not even a cheater, it's just your notes. You got to have those notes because it tells you how to do stuff. Okay, we did the step-by-step words together. And then we set you loose. 14, I remember one or two of you asking this. Remember how your vertex is always at HK wherever you move? What is the slope on the right-hand side of all these V's? Up 1 over 1, up 1 over 1, up 1 over 1. The slope on the left side just gets mirrored. Well, if we're used to the slope is 1 over 1, but the scale is going by 3s like this, well, that's kind of ugly. So what can I do to make it better? Instead of up 1 over 1 and ballparking it, anyone? We've done it enough times now. I can go up 3, right 3. Up 3, right 3. Okay? It's just the scales are different. That seemed to be the number one issue with these, not so much the graphing, left, right, up, down business for my vertex, but matching it to a scale that might be kind of goofy. If you don't like that this one is going by 2's, turn that into 2 over 2. Up 2 over 2. Up 2 over 2. Up 2 over 2. Up 2 over 2. You know what? You don't like that at all. Go up 5 over 5. Just make like 1 or 2 dots on both sides, connect the dots. That works too. So we have to be able to match these to a scale. Okay, 15 through 18. I know we say V's and these looks more like check marks, but that's just because that's the only part of the graph you can see. If you were to extend the graph, you're going to see the entirety of that V. If I gave you this without an equation, would you be able to write the equation? Like, I should look at it and see it's a V, it's pointy. I know its absolute value. I just have to figure out which way I went. This was like, what, 18 or something? I just got to figure out which way I went. So if I go right 4 and up 2, do you got those notes? Do you got that cheater to say where those numbers go? Left and right goes inside. Up and down goes outside. Outside the grouping, it's regular land. If I went up 2, I put +2. Inside the grouping is bass-backwards land. If I went right 4, I say -4. We should be able to construct the equation too, as long as we got that cheater written down. Oh, no. Zoom. Okay, 19, they ask me what the vertex is. A, that's a vocabulary term. B, y'all remember like back in middle school? Doing stuff like this? Remember the pointy parts, or in the case of a parabola, the bottom of that U or top of that U, those are called vertices. A vertex is anywhere that I change directions. Okay, like if I'm walking through the classroom and then I left rudder right here, that right there that I turned at is a vertex. I turned again, this is a vertex. Okay, anywhere that I change direction, those are vertices. So when they ask where's the vertex, there. It's the pointy part. It's where it changed directions. You just write that coordinate. Ugh. 20 is basically the same difference. They tried to make a word problem out of it, but failed miserably. It's just blah, 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 do what you did. Vocab is always, Frank, you rat, son of... Hey. Vocab is always on that first page, the little box off to the side. You just double check that you know what the words mean. And then down at the bottom, 23, some of us were struggling with the difference in terminology here. How do I know the difference between vertical and horizontal? How do you remember the difference? Okay, Leighton apparently does a little like dance. I think that's what that was. Oh, remember our x equals number and y equals number. X equals number was a vertical line. If you know that that equation looks like that, that'd be a good way to remember it. You can use other contexts. How about the horizon? Horizontal. The horizon goes this way, right? Okay, that's always the way that I remembered. A basketball player's got to have a good vertical, right? Up and down. Okay, doesn't look like it now, but you back up about 20 some years, I had a decent vertical. Actually used to crush our basketball players when we did our agility training in the weight room. Y'all do box jumps? That nice like 4 foot tall one? No problems. Thump, thump, thump. Do sets of 50. Oh yeah. Um, back in the good old days before children and the weight of the world. Um, if I have a horizontal translation, I just got to know horizontal is this way. So where do I put a number to move this way? Inside the grouping. This particular one is absolute value of x minus 1. They only moved right 1. This is absolute value of x plus 4. I put numbers outside the grouping to move vertically. And then this one, they did 2 at once. They did absolute value of x minus 1 plus 4. They put those two together and said I can do 2 things at once. Okay? All comes down to those notes. Do you have those notes about when I go right and left, up and down? If you got that and you know the parent function, you're good to go. So, Mom, I said, Mom, okay. I would like you to 3.7. Absolute value graphs. You're going to have 2 things to do here. First one, I want you to graph y equals absolute value of x minus 2 plus 1. But I also want you to write the equation for this graph. I'm going to put a graph here. You tell me what its equation is. Okay, so there are 2 different problems here. The first one, I want you to graph this blue guy. The second one, I want you to tell me what this equation is. All right? So 2 parts. No, you do not need to copy down the yellow graph. You just need to tell me what its equation is. So you should have one thing graphed and one thing written as an equation. Go back to your cheater, go back to those notes about what makes things move left and right, up and down. Where do I put the number? What is the sign? Okay? Give you about 5 minutes. fairly quick. Anyone need more? Yes, no? Speak now or forever hold your pieces. All right. I'll actually start with this guy since I got the graph right here. You. I see a V. Absolute value with X. I know I've got that much, right? Then, to get to this vertex, I went left 3, down 3. So left or right is where? Inside or outside the grouping? Inside. And inside the grouping, is it regular or bass-backwards? Regular or opposite signs? Opposite. Okay. So since I went left 3, I say plus 3. Bass-backwards. It's a loophole. Ha! And then if I went down 3, up and down, well, naturally I only got one spot left. It's outside the grouping, but it's regular signs, minus 3. Okay. Contestant 2, if I'm going to graphify that thing, then I'm going to move minus 2 in the grouping. Left, right, up, or down? Just going to keep saying things until I stop you, right? Go look at your cheater. Right. It is right. Inside the grouping is left and right. Opposite signs means right 2. Outside the grouping is up and down. Regular signs means positive is up. So I'm going to take a normal V and move it right 2, up 1. Then I'll make my slope on the right-hand side as up 1 over 1, up 1 over 1, up 1 over 1. On the left, I mirror it, up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1. Like so. I'm looking for, did you get the right values for inside and outside? Got your signs taken care of? Did you actually move that graph right 2 and up 1? And did you have the correct slope to it? Now, I'm not going to overwhelmingly punish you if maybe you got the whole inside is bass-backwards, outside is regular. You got that part right, but you swapped left-right with up-down. Maybe you swapped that part of it. I would say 1 off for each because you swapped what they meant, but you understood what the signs did. Okay? If maybe you got them in the right spots for this is left right, this is up down, but you did these signs are regular, these signs are opposite. Again, 1 off each. Not 1 off, 1 off, 1 off, 1 off, crap, I got a 1 out of whatever. Okay, we want to be reasonable. Anyone got questions about this? So here's the deal. I have the chapter 4 packets ready to roll. Bruh. But we have a quiz on Friday. I don't really want to start a new chapter for one section and then do a quiz, especially right before our next grade check. Quarter is next Wednesday, a week from today. I don't want to do that, so what I did yesterday and what I'm going to do for you today is we're going to go light on you. You are still doing stuff, don't get that excited. Okay, you are still doing stuff. What we're going to do is a little bit of practice. You show me you get these two things done, and then you're good to go. A, right after section 3.7 is progress check 3. It is practice with absolute value and quadratic graphs. Y'all remember the quadratics? It's been like a week and a half now. Remember the zeros are where it hits the x-axis? The maximum or minimum value on it? Okay, so progress check, and then if you look right after that, you should have this page. This is just more practice with all of the above. You look at the top row. The top row is graphing a quadratic by table. It's been like a week and a half. Do you remember how to do this? Do you remember how to get those parentheses going on your calculator? Do you remember what numbers I should put in? Remember, we start with 0. If it works, then I go to plus or minus 1. If they work, I go to plus or minus 2. Oh, wait, 2 doesn't work. It's not on my graph, so I guess I'll go to -3 and -4. Okay, you start at 0 in the middle and work your way out from that. So practice graphing those by table. Writing the equation using transformations. They all have a different parent graph. This is y equals x. This is y equals absolute value of x. This is y equals x squared. You have to rewrite the equation with, what did I do? Did I go up or down, left or right? Where is that in the equation? Inside or outside the grouping? Positive or negative? Okay, so you're going to rewrite those. You have to write the equation for those right after the progress check, the one right in front of your face. Right?
No. I think so.
Dude, after the progress check.
Got it.
The next set is describe the translation. So you tell me, what does a -4 outside the grouping do? Graph it. What does a +5 inside the grouping do? Graph it. And then down below that, some more practice with the absolute value. Sounds like we did okay with it, but I'm mixing it all together here. I'm hoping that by not going on to chapter 4, and by just getting another day of a little bit of practice with all of the above, we're going to go do our quiz on Friday, and we're just going to crush it. I'm hoping we're all going to crush that quiz on Friday so that our quarter 3 grades look real good. Also, that means you'll be able to turn in this 3B packet that day. So you will have another packet of notes and another quiz that goes on the quarter 3 grade check. Okay? If you can show me these two things, theoretically everything else in your packet, if you can show me this practice page and progress check 3 done, fine by me. After that, you do what you're going to do. If you have taken care of business and you are caught up and your packet is filled in, start to finish, if you just want to relax, okay. We'll get our review and quiz on Friday and you'll be golden, okay? We are near the end game. We are entering the 4th quarter, the 4th chapter. There are 79 calendar days left in the school year. That means a grand total of, where are we at? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 2, 23. You have 24 classes before finals. It ain't far. Okay? So that's what we're doing. Yes, ma'am. We'll just take care of it next week. You always get caught up. I'm not worried. Okay. So that's what we're doing. You got two teachers in here. Ask questions. Move around if you need to. Just make sure we're actually working.